Hello students. So today we are going to start the new topic. So as per your syllabus, this is the 7th topic and this is alternating current, and in short form we call it as AC. Okay, alternating current. Okay, in our previous topics, I mean in third topic, so I have studied the current electricity. Okay, so in that chapter we have studied about the direct current. So direct current means whose polarity will be same. We can say unidirectional current. So yavaglu hengiರ್ತದ, it is always in a positive phase. So this is called the direct current. This is direct current, right? And if I write direct, and you can also use the word steady current, steady direct current. If the current is like this, if the current is like this, so then we call it as this is the current versus time graph, current versus time graph. If the current is like this, so you call it as a variable DC current. This is variable DC current, this is the steady DC, steady direct current, variable direct current. Okay, if the graph is like this, so if I draw the current versus time, so this is time and this is current. Okay, so with respect to the time, if its value is continuously changing and the polarity is reversing, so such a current is called the alternating current. See, the word alternating means its polarity changes alternatively. Once it is positive for a particular time, and for a particular time negative, again for a particular time positive, negative. So for equal intervals of time, after equal intervals of time, it changes its polarity. Okay, alternatively it get positive charges, or you can say alternatively it get the positive terminal, or alternatively it become a negative terminal. So this is called alternating current. Okay, so here this is a graph for alternating current. For example I say, so its time period is 1 second. So total illinda illi tanka illi enagida 1 second aglatada. So for first half second, first half second it is in positive phase. For negative half, for remaining half time it become the negative. Okay, so once for particular time I call t half, it is positive, and remaining t half it is negative. Okay, ಹೆಂಗಾಗ್ತದೆ ಇದು? Suppose this is the AC source and these are the two terminals, first terminal, second terminal. So for half second it is positive. At that time, that half second it is negative. Okay, once a half second is completed, so for remaining half this become negative, this is positive. Okay, mat half second aita, mat it positive agtada, this is positive, this is negative. For next half, this become negative and this become positive. And see, the positive terminal is coming alternatively. So that's why the name become alternating current. Is it clear? Okay, how to define the alternating current? Okay, so first we should know the was the equation for alternating current. So practically it is found that the graph of current versus time, the graph of current versus time is like this. So like this, is it? So if I take in terms of time period, so the total time is called capital T, and the half of this one is T by 2, and quarter of this one is T by 4. This is T by 4, and this is 3T by 4, 3 by 4 times the time. Is it? Okay, if I convert the same thing in terms of angle, so see, this is the total 360. Okay, or I can call for this time I call this is T half, for complete this is T, and this become T by 4 and this become 3T by 4. If I write the same thing in terms of angle, this becomes 0, this is 90, and this is 180 degree, this is 360, this is 270 degree. So the time period T by 4, it analogous to 90 degree, and the time period T by 2, it analogous to 180 degree, and the time 3/4 of time period, it analogous to 270 degree. Is it? And the complete T, it is nothing but 360 degree. Is it? In the same way, I can write this is 90, now this is 180 degree, this is 270 degree, and this is 360 degree, or I can write 0 degree. Is it? Okay. So see at at 0 degree. So the value of the current at 0 degree, it was 0. Okay, so value of the current in case of 90 degree, in case of 90 degree, see here, this is having the maximum value, I call this is I, so it is I value. And at the time of 180 degree, again this is 0, 180 degree 0. In case of 270, this is minus, if it is I, the same distance is here, so this is minus I and this is minus I. In case of 360, again this is 0. In case of 360, this is 0. See the values of, here it is theta, I mean angles. Okay, here this is the value of current. So at 0 degree, it is 0, 90 degree maximum, 180, 0, 270 maximum in negative quantity, and 360 0 degree. Okay, and these values holds good with the variation of the sine function. So sine function gunta enagtada, ee variation namge possible agtada. So that's why we can write here. So maximum value of sine theta, this is 1. Okay, if I write here it is I naught, like a maximum value. So here the maximum value will be I naught. So okay, so sine of theta maximum is 1 and I naught into sine maximum is I naught. Sine maximum is equal to 1. So that's why I is equal to I naught into sine omega t. So this become the equation for the alternating current. This is the equation for alternating current. So why the equation is like a I naught sine omega t? So because of the maximum value of current is I naught and it is continuously varying. How it is varying? Sinusoidally it is varying with the time. Which one? The current is sinusoidally varying with the time. Is it clear? Okay. So then how to define that alternating current? See here, what about the magnitude of current? So for a particular time its value is this much, for particular value this much, and maximum, and become minimum become 0, then minus negative maximum, then negatively decreasing, okay, and become 0. So means the magnitude of current is continuously varying with the time. The magnitude of current is continuously varying with the time. And what about the polarity? For every t by 2 time it changing its polarity. For every t half it changing its polarity. So that's why I can use the sentence like the current whose magnitude changes continuously and polarity changes periodically. What do you mean by periodically? After regular interval of time. After particular regular interval of time, its polarity is changing like this. Agale na helidange ondsala positive, ondsala negative, one side. Okay, so after regular interval of time, its polarity is changing and continuously its magnitude is changing. Such a current is called alternating current. Okay, how to define the AC? So the current whose magnitude is changing continuously and polarity is changing periodically. So that is called alternating current, continuously and periodically. You should remind these two words. Okay, what's the expression for alternating current? So the current I, and see here the value of current is not a constant at all the time. So at a particular time its value is different. Okay, so at the current I at a time t, the current at a time t. So e time current estada, e time current ada, each time current estada, I can write it as the value of I is varying with the time function and this is I naught. So I equal to I naught into sine omega t. So this become the expression of alternating current. Okay, you may ask me how to get the alternating current. In a previous topic you have studied the AC generator. So ಅದರ ಮುಖಾಂತರ ಏನಾಗಿರ್ತದೆ alternating current ಡೆವಲಪ್ ಆಗಿರ್ತದೆ. ಸೊ AC ಜನರೇಟರ್ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು, ಇದು ಸ್ಟಡಿ ಮಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ ಅದೇ ಹೇಳಬೇಕಾದ್ರೆ ಮತ್ತೆ ಟೈಮ್ ಹಿಡಿತದೆ ಈಗ. ಓಕೆ, so this is expression and see I'll give a simple idea about the AC. So this is the AC source. And this is a circuit now. Okay, there are some components. It is a AC circuit. This is AC source. Okay, AC source ಆಗಿತ್ತಂದ್ರೆ I call this is first terminal, this is second terminal. I can't say like a positive terminal, negative terminal, because the terminal, I mean the polarity is periodically changing. For some time it is positive and for next same time it is negative. For next same time it become again positive like this. So that's why I can't say it is positive, it is negative. Okay, right. For example, as I switch on the battery, I switch on the AC source for example its time period is 20 seconds. Actually ಇಷ್ಟು ದೊಡ್ಡ ಟೈಮ್ ಪೀರಿಯಡ್ ಇರಂಗಿಲ್ಲ, ಜಸ್ಟ್ ಟು ಕನ್ವಿನ್ಸ್ ಐ ಆಮ್ ರೈಟಿಂಗ್ ದ ಟೈಮ್ ಪೀರಿಯಡ್ ಇಸ್ 20 ಸೆಕೆಂಡ್. ಅಂದರೆ ಇಲ್ಲಿಂದ ಹಿಂಗೆ ಆಗಲಿಕ್ಕೆ ಇದಕ್ಕೆ ಎಷ್ಟು ಬೇಕು, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ 20 ಸೆಕೆಂಡ್ ಬೇಕು. ಹಾಫ್ ಅಂದರೆ ಎಷ್ಟು ಆಗ್ತದೆ ರೀ, 10 ಸೆಕೆಂಡ್. ಹಂಗಾದರೆ ಎವ್ರಿ 10 ಸೆಕೆಂಡ್ ಫಸ್ಟ್ 10 ಸೆಕೆಂಡ್ ಪಾಸಿಟಿವ್ ಇರ್ತದೆ, ನೆಕ್ಸ್ಟ್ 10 ಸೆಕೆಂಡ್ ನೆಗೆಟಿವ್ ಆಗ್ತದೆ, ಮತ್ತು ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಪಾಸಿಟಿವ್, ಮತ್ತು ನೆಕ್ಸ್ಟ್ 10 ಸೆಕೆಂಡ್ ನೆಗೆಟಿವ್, 10 ಸೆಕೆಂಡ್ ಪಾಸಿಟಿವ್, 10 ಸೆಕೆಂಡ್ ನೆಗೆಟಿವ್, ಲೈಕ್ ದಿಸ್. ಸೊ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಪಿರಿಯಾಡಿಕಲ್ ವೇರಿಯೇಷನ್. ಓಕೆ, ಸೊ ಈ ಪೊಲಾರಿಟಿ ಏನಾಗ್ತದ, ರಿವರ್ಸ್ ಆಗ್ತದೆ ರೀ. ಸೊ ಫಾರ್ ಎವ್ರಿ 10 ಸೆಕೆಂಡ್ ದ ಪೀರಿಯಡ್ ಈಸ್ ರಿವರ್ಸಿಂಗ್. So that's why the AC definition become the current whose magnitude changes continuously and whose polarity reverses. See the word, whose polarity reverses periodically. ಅದ್ರ ಪೊಲಾರಿಟಿ ರಿವರ್ಸ್ ಆಗ್ತಿರ್ಬೇಕಾ, ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಟ್ಲಿ ನೆಗೆಟಿವ್, ನೆಗೆಟಿವ್ ಇದ್ದು ಪಾಸಿಟಿವ್, ಈ ಥರ ರಿವರ್ಸ್ ಆಗ್ತಿರ್ಬೇಕು ಅದ್ರದ್ದು ಪೊಲಾರಿಟಿ. ಯಾವಾಗ, ಪಿರಿಯಾಡಿಕಲಿ. ಓಕೆ, ಆ್ಯಂಡ್ ಸಿ ನಾವು ಈ ಥರ ಆಗಿದೆ 10 ಸೆಕೆಂಡ್ ಅಂತ ತಗೊಳ್ರಿ ಇದು. ಸೊ ಟೋಟಲ್ ಟೈಮ್ ಪೀರಿಯಡ್ 10 ಸೆಕೆಂಡ್. ಹಂಗಾರೆ ಎವ್ರಿ 10 ಸೆಕೆಂಡ್ total time period 20. For every 10 second it changes the polarity. It changes the polarity. Okay, so as I switch on the AC source, so this is positive, this is negative for 10 second. For 10 second, at that time the electrons start to move like this. Electrons start to move like this. Is it? As a result the current, okay, electron hinge, electron illi barlatav. As a result the current move in this direction. ಹೌದಲ್ಲ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್. 10 ಸೆಕೆಂಡ್ ಆಗೋಗ್ಬಿಡ್ತು, 10 ಸೆಕೆಂಡ್ ಆಗೋಗ್ಬಿಡ್ತು, ಅವಾಗ ಇದು ನೆಗೆಟಿವ್ ಆಯಿತು, ಇದು ಪಾಸಿಟಿವ್ ಆಯಿತು, ಸರಿನಾ? ಅವಾಗೇನಾಯಿತು, ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ಬರ್ಲಾತಿದ್ದಿಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ ಹಿಂಗೆ ಹೋಗ್ಲಾಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತಾವ, ಎಲೆಕ್ಟ್ರಾನ್ ಹಿಂಗೆ ಹೋಗ್ಲಾಕ್ಕೆ ಚಾಲೂ ಮಾಡಿದ್ದು ರೀ ಅವಾಗ ಹಿಂಗೆ. ಅವಾಗ ಕರೆಂಟ್ ಏನಾಯ್ತು ರೀ, ಹಿಂಗೆ ಬರ್ಲಾಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತಾ. ಫಸ್ಟ್ ಕರೆಂಟ್ ಹಿಂಗೆ ಹಿಂಗೆ ಹೊಂಟಿತ್ತು ರೀ, 10 ಸೆಕೆಂಡ್ ಆದಮೇಲೆ ಹಿಂಗೆ ಬರ್ಲಾತದ, ಮತ್ತು 10 ಸೆಕೆಂಡ್ ಆದಮೇಲೆ ಕರೆಂಟ್ ಹಿಂಗೆ ಬರ್ತದೆ, ಮತ್ತು 10 ಸೆಕೆಂಡ್ ಆದಮೇಲೆ ಕರೆಂಟ್ ಹಿಂಗೆ ಬರ್ತದೆ. ಹೌದಾ? ಸೊ ಇಟ್ ಈಸ್ ನಾನು ನಿಮ್ಗೆ ಕನ್ವಿನ್ಸ್ ಸಲುವಾಗಿ 10 ಸೆಕೆಂಡ್ ಟೈಮ್ ಅನ್ಲಾತೇನ. ಓಕೆ, ಬಟ್ ಇನ್ ಫ್ಯಾಕ್ಟ್ ದ ಟೈಮ್ ಪೀರಿಯಡ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್. ದ ಟೈಮ್ ಪೀರಿಯಡ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್. ಸೊ ಒಂದ್ಸಲ ಎಲೆಕ್ಟ್ರಾನ್ ಇದು ಪಾಸಿಟಿವ್ ಇದ್ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಹಿಂಗೆ ಹೊಂಟಿತ್ತು. ಓಕೆ, ಇದು ನೆಗೆಟಿವ್ ಆದಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ ಹಿಂಗೆ ಹೋಗಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತು, ಮತ್ತು ಹಿಂಗೆ ಹೋಗಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತೀವಿ, ಮತ್ತು ಹಿಂಗೆ ಇದೇ ಫಾಸ್ಟ್ ಆಗ್ಲತ್ತಿತ್ತು. ಸೊ ಅವಾಗ ಏನಾಯ್ತಾ, ಇಟ್ ಈಸ್ ಪಾಸಿಟಿವ್. Now the electron start to move here. Okay, so suddenly this become negative, it start to move here, positive here, negative here, positive, negative. So the electron start to vibrate about their mean position. It start to vibrate about their mean position in that circuit. As a result of vibration of the electron, as a result of vibration of free electrons in the circuit, there okay, it constitute AC in the circuit. ಓಕೆ, ಹಂಗಾರೆ ಒಂದು ಸರ್ಕ್ಯೂಟ್ದಾಗ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಹೆಂಗೆ ಕನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗ್ತದೆ, ನಾವು ಎ ಸಿ ಸೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡೋದ್ರಿಂದ ಕನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗ್ತದೆ. ಸೊ ವಾಸ್ ದ ಎಕ್ಸಾಕ್ಟ್ ಮೆಕ್ಯಾನಿಸಮ್. ನಾವು ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್ ಅಂತ ಹೆಂಗೆ ಅಂತೀವ, ಒಂದು ಸೈಡಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತಾವೆ ಹಿಂಗೆ, ಅದ್ರ ಅಪೋಸಿಟ್ ಸೈಡ್ದಾಗ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗತ್ತದ ಅಂತ ನಾವು ಹೇಳಿಬಿಡ್ತೇವೆ ಹಿಂಗೆ. ಓಕೆ, ಇಟ್ ಇಸ್ ಯೂನಿ ಡೈರೆಕ್ಷನಲ್. ಬಟ್ ಇಲ್ಲೇನಾಗ್ತದ, ಎಲೆಕ್ಟ್ರಾನು ಒಂದು ಸಲ ಹಿಂಗೆ ಹೋಗ್ಬೇಕಂತಿರ್ತದ, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಚೇಂಜ್ ಆಗ್ತದೆ ರೀ, ಅವು ಹಿಂಗೆ ಹೋಗಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತದೆ, ಮತ್ತು ಟೈಮ್ ಚೇಂಜ್ ಆಗ್ತದೆ, ಹಿಂಗೆ ಹೋಗಕ್ಕೆ ಚಾಲೂ ಮಾಡ್ತದೆ. ಸೊ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಟಾರ್ಟ್ ಟು ವೈಬ್ರೇಟ್ ಅಬೌಟ್ ಇಟ್ಸ್ ಮೀನ್ ಪೊಸಿಷನ್. The electrons start to vibrate about mean position. Okay, if the free electron is vibrating, all the free electrons in the circuit are vibrating about their mean position, then there will be AC. If all the free electrons are moving in a particular direction in the circuit, that is DC. ಎಲ್ಲ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ದಾಗ ಮೂವ್ ಆಗ್ಲಾತಿದ್ದು ಅಂದರೆ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್ ಇರ್ತದ. ಅದೇ ಸರ್ಕ್ಯೂಟ್ದಂದು ಎಲ್ಲ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಅವ್ರ ಮೀನ್ ಪೊಸಿಷನ್ದಾಗ ವೈಬ್ರೇಟ್ ಆಗ್ಲಾತಿದ್ದು ಅಂದರೆ ಅಲ್ಲಿನೂ ಕರೆಂಟ್ ಇರ್ತೈತಿ. ಅದೆಂಥ ಕರೆಂಟ್, ಎ ಸಿ ಕರೆಂಟ್. ಓಕೆ, ಆ್ಯಂಡ್ ವಿ ನೋ ವೈಬ್ರೇಷನ್ ಇಸ್ SHM, simple harmonic motion, and we know the expression for simple harmonic motion, y is equal to a into sin omega t. The same thing here, I equal to I naught into sin omega t. So where I naught is the maximum value of this function, is the maximum value. So I call this is the amplitude. So this is maximum value, or you can say the current amplitude, where I naught is equal to maximum value of current, or it is called the peak current. This is called peak current, or it is also called current amplitude. So this value here to here, the maximum value of the current in a particular phase, so that is called the I naught. You can write the peak current or peak value of current. Is it clear? Okay, in the same way we can write the expression for voltage, so that is V is equal to V naught into sin omega t. In the same way we can write the expression for EMF, electromotive force, that is E is equal to E naught into sin omega t. So what do you understand by knowing these three equations? It means in case of AC, the value of current is continuously changing. At a particular time we can get the current value. At a particular time we can get the voltage value. At a particular time we can get a EMF. Means with respect to the time, EMF, voltage as well as current changes. If you want to get the voltage, you need to mention at what time you are getting. If you want to get the EMF, you should mention at what time you are mentioning the EMF. At what time you are getting the current. So with respect to the time, current is changing. I mean with respect to time, voltage is changing. I mean with respect to time, the EMF is changing. So these are the three important equations. Okay, so V equal to voltage at a time t. What is the V naught? It is peak value of voltage. And this is the EMF at a time t. EMF at a time t. Then what is the E naught? E naught is a peak value of EMF. Peak value of voltage, peak value of EMF, and the peak value of current. Okay, and remaining these values are varying sinusoidally. All the terms like a current, voltage, and EMF are varying sinusoidally. Is it clear? Okay, so usually while studying the AC, we used to take the RMS values. RMS value means root mean square value. So which you are studying in your PUC first year about the RMS velocity. So like this. So yakant helidre, for example, the AC is like this. You can write the AC current or you can write the AC voltage, right? So I want to take the average of the total current. So total ಅಲ್ಲಿ current particular time ಗೆ change ಆಕೋತ ಹೊಂಟದ. First time ಅಲ್ಲಿ ಹಿಂಗದ, next time ಅಲ್ಲಿ ಹಿಂಗದ, next time ಅಲ್ಲಿ ಹಿಂಗದ, next time ಅಲ್ಲಿ ಹಿಂಗದ. So continuously varying up to a particular time and decreasing, and it changes its polarity like this. I want to get the average value because I can't mention the current at 0.3 second is this much, 0.4 second this much, 0.5 second this much. So I should mention on an average was the current in that circuit. So usually while studying the AC, we used to write the RMS value of current. So RMS value of current means, so it is the on an average of the total quantity. Total quantity, the on an average value S2. We used to write RMS. So how to write the RMS? So there is a formula. IRMS means RMS value of current is equal to peak value of current divided by square root of 2. Peak value of current divided by square root of 2. In the same way, you can write the RMS value of voltage, because in case of AC, voltage is also continuously varying. It is also sinusoidally varying with the time. So once it is positive, once it is negative, once it is 0, like this. So we used to take there is a AC source of battery 220 volt. So there is AC source of 220 volt. What do you understand? So there is a AC source and its RMS value is 220. And there is a AC source of current 2 ampere. What do you understand? They are mentioning the RMS current. They are mentioning RMS voltage. So we can specify a particular AC device by its RMS values. So not a average mean value nam tolak barangile. For example, if you take the mean current ing togota hogri, ಏನು ಮಾಡ್ತೀರಿ ನೀವು? You add all the values and divide by number of turns. For example, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ನಾನು 10 section ಮಾಡ್ಕೊಂಡ. So 10 seconds ಎಲ್ಲ ವ್ಯಾಲ್ಯೂನ ಆ್ಯಡ್ ಮಾಡಿರಿ. So 1, 2, 3, 4, 5, 6 like this. So these three are positive and equal values are negative. They cancel with each other. And here, so this is this term and this term cancels. This term and this term cancel. This term cancel. So that the mean value becomes 0. If you start to take in ordinary mathematics like adding all the terms divided by number of terms. So that's why we use the RMS concept. So in case of voltage, this become V naught by root 2. Okay, you must mention these two equations. IRMS equal to peak value of current divided by root 2. VRMS equal to peak voltage divided by square root of 2. Okay, and at the next point, phasor. Phasor, I think it's a new word for you. So what's a phasor? So phasor is a vector quantity, or you can say it is a rotating vector. Means you can represent that vector in all 360 degree. You can represent that vector in all 360 degrees. So that's why we call it as it is a rotating vector. So ಯಾವುದಕ್ಕೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೇವ? Is a rotating vector that represents sinusoidal variation of a quantity. So ಯಾವುದೋ ಒಂದು ಕ್ವಾಂಟಿಟಿ ಸೈನೋಸಾಯ್ಡಲಿ ಅಂದರೆ ಏನು? ಇಟ್ಸ್ ವ್ಯಾಲ್ಯೂ ಶುಡ್ ಬಿ 0, ಮ್ಯಾಕ್ಸಿಮಮ್ 0, minus maximum, negative maximum, again 0, next positive maximum 0, negative maximum 0. So there must be a sine wave. So such a variation is called a sinusoidal variation. Suppose a quantity is varying sinusoidally, then we can represent it by a particular rotating vector. For that rotating vector we call the phasor. We call it as phasor. Next time phasor diagram draw ಮಾಡಿ ತೋರಿಸ್ತೇನೆ ನಿಮಗೆ, ಅವಾಗ ಗೊತ್ತಾಗ್ತದೆ. And the next point is about phasor diagram. Was a phasor diagram. So this is a diagram which represents the sinusoidal variation of two quantities simultaneously with respect to the time. So ಒಂದು diagram ಅಲ್ಲಿ ಎರಡು ಕ್ವಾಂಟಿಟಿಗಳು ವೇರಿಯೇಷನ್ ಆಗ್ತಿರಬೇಕು. ಹೆಂಗೆ ವೇರಿಯೇಷನ್ ಆಗ್ತಿರಬೇಕು? ಸೈನೋಸಾಯ್ಡಲಿ ವೇರಿಯೇಷನ್ ಆಗ್ತಿರಬೇಕು. ಸೊ ದ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಆಫ್ ಟೂ ಕ್ವಾಂಟಿಟೀಸ್ ವಿಚ್ ಆರ್ ವೇರಿಯಿಂಗ್ ಸೈನೋಸಾಯ್ಡಲಿ with respect to the time. So that diagram is called the phasor diagram. Okay, agar phasor diagram andre ಏನು? The diagram which represents the sinusoidal variation of two quantities with respect to the time. Let's see here, for example, there is a AC source and it is connected to a particular circuit. Now if I want to represent the current as well as voltage, I write it like a I naught into sin omega t. I write it like a V naught into sin omega t. Okay, in this circuit both current and voltage are varying sinusoidally with respect to the time ತಕ್ಕಂಗೆ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಗ್ಲತ್ತದ, ಸೇಮ್ ಟೈಮ್ ತಕ್ಕಂಗೆ ವೋಲ್ಟೇಜ್ ಚೇಂಜ್ ಆಗ್ಲತ್ತದ, and that variation is about the sine function. So that's why we can represent both voltage and current in a single diagram by writing two phasors. So that diagram is called the phasor diagram. What do you understand? So phasor means it is a rotating vector which can represent the sinusoidal variation of particular quantity. What is the phasor diagram? So diagram which is the diagram which represent the sinusoidal variation of two quantities with respect to the time. ಎರಡು ಕ್ವಾಂಟಿಟಿ ಸೈನಸಾಯ್ಡಲ್ ವೇರಿಯೇಷನ್ ಆಗ್ತಿರಬೇಕು, ಆ ವ್ಯಾಲ್ಯೂನ ಅಟ್ ಅ ಟೈಮ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕಾ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ದ phasor diagram. Okay, next point is AC voltage applied to a resistor. Okay, so here this is the resistor and this is AC source, and here the symbol for AC source is like this. So you should write a wave, ಒಂದು ವೇವ್ ತೆಗಿಬೇಕು, ಅದ್ರ ಮೇಲೆ ಹಿಂಗೆ ಸರ್ಕಲ್ ಹಾಕಬೇಕು. ವೇವ್ ಅಂದ್ರೆ ಏನು? ದ ವೇರಿಯೇಷನ್ ಆಫ್ ದ್ಯಾಟ್ ಕರೆಂಟ್ ಈಸ್ ಸೈನಸಾಯ್ಡಲಿ, ಈ ಥರ. ಅದಕ್ಕೆ ಇದಕ್ಕೆ ಏನಂತ ಕರೀತಾರ? AC source. ಸೊ ಈ ಥರ ಮಾಡಬೇಕ್ರಿ ನೀವು ಹಿಂಗೆ. ದಿಸ್ ಇಸ್ AC source. Okay, whenever the AC source is connected to a resistor, then we call that circuit as a pure resistive circuit. It is pure resistive circuit, or you can simply call it is a resistive circuit. What do you mean by resistive circuit or pure resistive circuit? So whenever AC source is connected to a single resistor only or a resistor only, if the AC source is connected to resistor only, then we call that entire circuit as a resistive circuit, or you can say pure resistive circuit, right? Okay, ಇಲ್ಲಿ ಹೆಂಗೆ ಚೆಕ್ ಮಾಡೋದಂದ್ರೆ ನಾವು, ಸೊ ಇಫ್ ವಿ ಅಪ್ಲೈ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ವೋಲ್ಟೇಜ್ ವಿತ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೇಸ್, ಸೊ ವಾಟ್ ಶುಡ್ ಬಿ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕರೆಂಟ್, ಅದನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕಾ. ಓಕೆ, ಸೊ ಲೆಟ್ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ ನಾಟ್ ಇಂಟು ಸೈನ್ ಒಮೆಗಾ ಟಿ be the applied voltage here, be the applied voltage. Next, what may be the value of current in the circuit? So if you want to get the current, then current equation I is equal to we write it as V divided by R. So okay, I equal to V divided by R. So totally ನೀವು ಹೆಂಗೆ ನೆನ್ಪಿಟ್ಕೋಬೇಕಂದ್ರೆ ಇದನ್ನ current is equal to voltage divided by opposition. voltage divided by opposition, and that opposition is by the resistance of the resistor, so that's why it is R. Okay, and the next step, so I is equal to, so V value, we know the V value, so that is V is equal to, right here, this is the V value, and substitute this value here, so V is V naught into sin omega t divided by R. Okay, so I'll write it as I is equal to V naught by R into sin omega t. Okay, was a V naught is a peak value of voltage, somehow it is voltage only, so voltage was R, it is the opposition, so that's why peak voltage divided by opposition, that will give you the peak current. Current equal to, sorry, voltage divided by current is voltage divided by opposition is current, voltage by opposition is current, peak voltage divided by opposition is peak current, is it? So if it is a ordinary voltage, you will get a ordinary current. If it is a maximum current, you will get the maximum, sorry, if it is a maximum voltage, you will get maximum current. So that's why for this one I call the I naught. Then the equation become I is equal to I naught into sin omega t. So this is our equation. So what is the voltage equation here? Voltage equation is V equal to V naught sin omega t, and current equation is I equal to I naught into sin omega t. Compare these two equations, voltage and current. What about the phase difference between voltage and current? What are the phase difference? Phase difference andre angular difference estada. Here the angle is theta equal to omega t. Here the angle is also theta equal to omega t. Means both are in the same phase. Both are in the same phase. So you can call phase difference is 0. Phase difference is 0. Then how to represent this one? So we can represent it in two ways. So first one by the wave diagram, and the other one is by the phasor diagram. Phasor diagram and wave diagram. Okay. Right. So wave diagram ಹೆಂಗೆ ಆಗ್ತದ ನೋಡಿ ಇಲ್ಲಿ, this is the y axis and this is x axis. Along the x axis we represent the time, which is independent quantity, and here I can represent both current and voltage, current and voltage. Okay, so first I'll write the value of voltage, or draw the voltage by the dash line. So like this. This is the voltage. And what about the current? See this here. So when both are having the same phase, means both attain the maximum value at the same time, both attain the minimum value at the same time, both attain the 0 at the same time. Which are those both? Both means current and voltage. Okay, so when voltage is 0, current is also 0. When voltage is maximum, current is also maximum. When again voltage 0, the current is also 0. When the voltage is minimum, means negative value of the voltage, the current is also minimum. Again when voltage is 0, the current is also 0. Okay, now this is like this. Okay, and this dash line is the wave for voltage, and this line, this is a wave for the current. This is current wave and this is a voltage wave, and see both attain the 0 at the same time, both attain the maximum at the same time, both attain the maximum minimum at the same time. So that's what we call there is no phase difference. There is no phase difference. And observe the diagram, the magnitude of current is lesser than the voltage. Magnitude of current is lesser than the voltage. Is it? Okay, in case of a phasor diagram, so we should represent a diagram in which there must be the representation of two sinusoidally varying quantities. Now the current and voltage both are varying sinusoidally. So first I represent the voltage value. This is the voltage, and I can represent the current. I can represent the current. So with the same angle, see here, and this is current. Okay, so this is current and this is the voltage. Both are having the same angle. So what is that angle? So that is theta is equal to omega into t. Omega into t. So this is phasor diagram. Here there are two vectors. One is voltage vector and the one is a current vector. So I can say there are two phasors, voltage phasor and current phasor. Both are at the same angle. So that's why there is no phase difference between the current and voltage. Is it clear? Okay. And next here one more information. The average current over a complete cycle, the average current over a complete cycle is always 0. How do you say? For example, here it is 1, 2, 3, 4, 5 and again 4, 3, 2, 1, 0 and minus 1, minus 2, minus 3, minus 4, minus 5. This minus 5 cancelled by this minus 5 and this 5 readings cancelled by this 5 readings. So like that the total current over a complete cycle is always 0. But it doesn't mean that average power is equal to 0. Is it clear? Average current over a complete cycle is 0, but the average power for a complete cycle is not equal to 0. Yaka not equal to 0 agtada? Yak not equal to 0 agtada? Because the formula for power is equal to I square into R. The value of power is I square into R. So here we take the positive or negative, the square term will be the positive only. So that's why the power never be 0 in case of the resistor. In case of resistor, power is not equal to 0. And if you want to get the average power, so there is a one more way. So that is P is equal to we take the RMS value of current and square it and resistor. So that will give you the power is equal to I RMS square into R. So the conclusion is the total current or the mean value of current over a complete cycle is 0, but the power over a complete cycle is not equal to 0. Okay, so this is about the resistive circuit. Means whenever the voltage applied to a resistor, the voltage and current they will be in same phase. There is no phase difference. Both will attain the maximum value and minimum value at the same time. Okay.